Okay, we're going to run with 3 videos today. Okay, first one is going to be absolute values, and we're going to be talking about equations. Second video, we're going to be talking about absolute value inequalities, and we'll be talking about if there's a less than sign, and then we'll talk about absolute value inequalities if there is a greater than sign. Okay, so let's go ahead and get started with this first video. First, I want you guys to pause this video, and I want you guys to jot down everything you guys can think of for your absolute value. So pause the video, jot down everything you guys can think of for an absolute value. Okay, absolute value. Some of you guys might have written down an example. Might have been like absolute value of -8. What is the absolute value of -8? That's 8. Some of you guys might have been like, okay, absolute value gets rid of negatives. Okay, that's kind of an arbitrary thing. That's not, it is, but it's, why is it doing that? Well, the reason that it is doing that would be our definition of an absolute value. And the definition of an absolute value is the distance from a real number to 0. So why does it get rid of the negative? Well, because it's talking about a distance, and you can't go a negative distance. So that's why the negative is no longer there. Some of you guys might have drawn a picture of the absolute value function, that it is a v. Okay. Any other thing you guys might have jotted down, might want to share at the beginning of the class, feel free to do so. Okay. Now, some things with absolute values that we need to know. Absolute value of a is always greater than 0. All that's saying is that your answer can't be negative. Which makes sense. When we were doing the absolute value of -8, that equaled 8, right? So that one worked there. Okay. Also with absolute values, absolute value of a equals the square root of a squared. We've done that one before. This is one that we haven't talked about before, but if you are multiplying two things inside an absolute value, you can split the two absolute values. And then the last thing is that the absolute value of u equals a. And what that tells us is, that tells us that, hold on, I'm trying to select this object here. That tells us that u, the part that is on the inside, there could equal a positive or a negative a. Okay, so now what is that telling us? Well, that's telling us if I had an absolute value of x equals 7. A lot of you guys would say, okay, well, x would equal 7. And that would make that true, right? Because the absolute value of 7 is 7. However, some of you guys would be like, hey, though, I could plug a -7 in for that. And I could say that the absolute value of -7 also equals 7. So what that's telling us is that if the absolute value of x equals 7, that means that x could equal 7 or could also equal a -7. Okay, and that's important. So what's on the inside there could equal a positive or it could equal a negative. And that's going to come into play when I'm solving equations here. Okay, so closer look at absolute value of u equals a. U could equal a positive or a negative a. So whatever's on the inside, if you have something on the inside of the absolute value signs and it equals a, that part on the inside could equal a positive a or a negative a. And our example that we did on the last slide there was that if I had an absolute value of x equals 7, there are two things that could be plugged in for the x to make that statement true. Okay? Two things could go in there. You could have an absolute value of 7, or you could have an absolute value of a -7, and both would make that true. Okay? So when I'm solving this equation down below, absolute value of x plus 4 equals 13, what's on the inside here, that x plus 4, could equal 13, right? And that would make that statement true. I could say that x plus 4 could equal 13, and that would make that true. However, x plus 4 could also equal a -13, and that would still make that true. Okay? So, important thing that we need to cover here. When we are solving equations with an absolute value, okay, remember solving equations, our main goal is we're trying to get x by itself. Okay? Well, the absolute value bars are in the way of that right now, right? Absolute value bars are in the way. So how do you get rid of absolute value bars? Well, I get rid of the absolute value bars by writing two equations. Now my absolute value bars are gone there. Okay, and the reason we do that is for this statement right up here. The part on the inside could equal a 13 or it could equal a negative 13 and it would still make that true. So when you guys are solving these absolute values, you're going to, first step is set up two equations. One with the positive 13, one with a negative 13. Once I do that, I just solve, subtract 4. Whoops. When I subtract 4, I get that x equals 9. On the other side, if I subtract 4, I get that x equals negative 17. So just like with our quadratics, when we are solving with absolute values, you guys are going to get two answers. And you guys can see, if you guys remember the shape of our graph, absolute values are going to be v's. So if I had an absolute value of x plus 4 equals 13, and I move that 13 over to the other side so that I can substitute my f of x in, if I graph this function here, you guys can see one of our answers is at negative 17, our x-intercept. The other answer is at 9. Okay? So based on the shape of that function, the fact that it's a v, it's going to give you guys two answers. Okay. Then, one more thing. You will not always have your absolute value. So in this case right here, I cannot say that 1 minus 4t is 13 and negative 13. I can't say that because my absolute value isn't by itself. I don't know what this absolute value equals yet. So earlier when I said your first step is to set up two equations, I actually lied. Our very first step that we have to do is we have to make sure that we isolate the absolute value. Okay? So I am going to subtract 8 to both sides. And when I do that, I get a 1 minus 4t equals 5. Now I can say, okay, 1 minus 4t could equal two things. It could equal a 5. 1 minus 4t could equal a 5. Or 1 minus 4t could equal a negative 5. Both of those statements would end up making that true. Okay? So, steps now, they've kind of changed our order here. First step, isolate the absolute value. Now that I've got it isolated, now I can set up my two equations. Okay? Now I'm ready to solve. So that's actually a positive 1, so we need to subtract 1. And I don't know why I wrote that in both spots. I would just solve each of these equations individually. I think that's easier. So I've got a negative 4t equals 4. Now I need to get rid of the negative 4t, so I'm going to divide by a negative 4 on both sides. I end up with a t equals negative 1. And then over here, same steps. I'm going to subtract 1. Okay, once I subtract 1, I've got a negative 4t equals a negative 6. Then I'm going to divide both sides by negative 4. And when I do that, I end up with a t equals, two negatives make it positive, and 6/4 reduces to 3/2. So there are my two answers for solving equations. Okay, next slide here, we've got some examples. Talk about the middle one real quick. Some of you guys are going to want to distribute on the middle one. You cannot do that. Those are not parentheses. If I want to isolate this middle problem here, that's a 2 times the absolute value. I need to use the inverse. So I can divide by 2, which would give me an absolute value of 6x plus 1 equals 5. That's how I would isolate that middle one. Go ahead and pause the video and finish those up for me. Okay, hopefully you guys have that video paused. We're going to go ahead and finish these up here and finish up this first video. Okay, I need to isolate, so I'm going to add 3. Gives me an absolute value of 3x minus 1 equals 13. Okay, now I'm ready to set up my two equations. 3x minus 1 equals 13, and 3x minus 1 could also equal a negative 13. Okay, we're going to add 1 to both sides. Gives me 3x equals 14. Divide both sides by 3, and I get x equals 14 over 3. That seems like a weird problem. I hope I didn't accidentally mess something up. Okay, then again, we're going to add 1 to both sides. 3x equals negative 12. Divide both sides by 3, and I get that x equals negative 4. Okay, so no issues there. We talked about this one. We would need to divide by 2 to get rid of that 2 there. gives me an absolute value of 6x plus 1 equals 5. So that 6x plus 1 on the inside, that could equal 5. Or that 6x plus 1 could equal negative 5. Both would make that true. Subtract by 1 gives me 6x equals 4. Divide by 6, x equals 2/3. Bottom one, subtract 1 over. I get 6x equals negative 6. Divide both sides by 6. I get x equals negative 1. And if you guys went through and spent a whole lot of time on this problem here, that was kind of a waste. Because right now, you've got the absolute value of 2x plus 4 equals a negative 8. And can absolute values equal a negative number? The answer is no. It's not possible. No matter what I plug in here, no matter what I plug into this spot, it is impossible. It's impossible. That is not how you spell impossible. I'm sorry. Is it how you spell it? Is there two M's? I don't know. Whatever. Not possible to do. I should have just wrote not possible instead of impossible. So since it is not possible, we just write no solution on that one there. Okay? And that's all for your solving equations with absolute values.